Okay, so be quick. My name is Joe Guadagno. I am what we call a senior director of technology. I lead 5 teams of software developers here. A little bit about me. You can reach out to me in many of these ways. Jay Guadagno on Twitter, Joseph Guadagno Net on Facebook, Joseph Guadagno LinkedIn, my website, jjg.me/about_jjg. And I used to stream. I don't stream much anymore, but you can at least go there and see some of the recordings. Enough about me. We're here to talk about patterns and practices with software architecture. Um, the key to this talk, or the key to this, is really understanding that patterns exist all around us. Like Mahesh was mentioning, when you're architecting a building, there's certain patterns that are followed. The blueprints are done. Once the blueprint is there, there's generally a layout of the floor, layout of the walls, and then inside the walls, the electrical, plumbing, etc., ventilation, and so on. These are patterns that exist in everything. When you build a car generally has 4 wheels and or 2 wheels if it's a motorcycle, generally has windows, generally has a door, an engine, etc. You'll see these patterns in software development a lot. I'm going to talk through some of them. Remember, patterns are there for one reason, so that you don't reinvent the wheel. And that's what this talk is going to be about. I'm going to walk through and show you some patterns and practices that I've seen over the years and that are pretty common. There's lots of books written on it. The most common one is known as the Gang of Four. Four software architects put together a list of the common patterns. You'll hear those scattered throughout. Now, as I talk about these patterns, these are things I've seen over time. No one is better than the other. They all have use cases where they shine, and some of them don't shine. So I'll talk to some of the pros and cons of each of them. And ultimately, it's up to you to decide what makes sense for your application. So let's talk about the first one, which is probably the most common that we've seen over time. And that's the layered multi-tier, or commonly referred to back in the late 90s, early 2000s as the three-tiered application. Three-tiered application is basically separating out the responsibilities of the application into these 3 tiers. It could be more depending on how you architect the app, but the 3 tiers is the most common. You have your presentation tier, which could be your mobile application, your web application. Really depends on how you do it, but basically the presentation, this is what the user sees. And then there's the logic tier, or service tier, or manager tier, depending on the organization you're part of. And this is the intelligence on what to do. For a lot of these samples, I'm going to be talking about a fictitiously large company called Amazon that does a lot of online orders. In this particular example, the logic tier, this is where you host things like how to place an order, how to ship an order, how to check the accounts, all that stuff, all that business intelligence. And then you have the data tier, and this is where you store it, your database backend that stores each of your clients or customers, all your orders, all your products. Now, the reason why you're doing this separation is so that one layer doesn't necessarily care about it. So if you're the web developer and you're building, let's say, Amazon.com, and you're looking for a list of products, you shouldn't have to care if the products are stored in a SQL database or an Oracle database or an AS400 or someone's floppy disk on someone's desk. Hopefully it's not a floppy disk on someone's desk, but either case, you shouldn't care. And that's where the logic and the data tier comes in. The logic says, hey, I want a list of products that Joe is going to be interested in. Logic layer says, okay, I know how to do that. It goes down to the database tier and says, hey, give me a list of all these things. And then it propagates upwards, in relationship to this diagram. Some of the advantages of this approach, you have a common thing that architects look to do, separation of concerns. Again, the presentation layer doesn't care about where the data is stored. You minimize the dependencies. I don't need to install a SQL client in my presentation tier. I don't need to care about how it's handled. Usually development is simpler because you can hire a UI person for presentation here. It doesn't necessarily need to know about database, a backend person for the logic tier. So he or she doesn't need to know about the UI. And it's reusable. This logic tier and database tier can be used over and over again, and the mobile tier can just be written and customized for that one individual person. Some additions or some disadvantages to this, the data model tends to move downward, meaning that the presentation tier kind of dictates how the data is stored. If you're not doing this right, you end up just repeating the same stuff all the way throughout. Generally, more code is needed. And in a situation like Amazon.com, that makes sense because you want to have that separation and you have the different teams. But in a smaller app, it might not make sense for you to break out your app this way. But one of the things to keep in mind, your app might be small now, but as Mahesh was mentioning earlier, you want to plan for 5 to 7 years. Let's say you build a small app just to keep track of, the podcasts you want because you were home by yourself for 2 years thanks to COVID, and you built a list to kind of cycle through all the podcasts. Well, your friend heard about it, your friend's friend heard about it, your friend's friend heard about it, and now you have 1,000 users or 2,000 users. So you want to build for the future, but not over-architect things. So let's move on to the next layer, which is a common one, especially in the ASP world, the ModelViewStar. And the reason why there's a star here is there's slight variations of this. There's the Model View Controller, or MVC. That's a pattern that became popular in the .NET world in the late 2000s. It's been popular in the Ruby world and pretty much every other software development language world for a while. There's some variations like the Model View Presenter, or MVP, or Model View Model, which is MVVM in the old Silverlight days and WPF days. But essentially, with this model, or with this pattern, you have the model that starts off in the upper part of this diagram. That model gets displayed to the view on the left-hand side or right side, depending on how the screen repeats. That view is responsible for showing the data, basically shows the model. That view is then presented to the user. The user interacts with that model and that view, and then does something that goes to the controller. So in the case of the orders, let's just say we're displaying a list of orders. The user goes to Amazon.com. They want to see a list of products. The controller says, here's a list of the products. It gives a list of models. The view says, okay, I'm going to display these. User gets a list, and now I can go and add it to the cart. I click add to cart. It goes to the controller, says, oh, this person wants to add it to the cart. I go and add it to the cart. I show a new cart or a new model with the cart information, which then goes to the view, and it's just this constant circle of back and forth and back and forth. This has some advantages to it also, like, again, separation of concerns. You have your view. As long as there's a model designed, you can have your UI handled by one set of people. Another set of people can handle the controller part of it, and then you have the user in between. With this model, the presentation layer tends to be more usable because you can build components for displaying a card or displaying a person or displaying a product that can be used in multiple parts of the application. And this allows for those specialized roles. Like you can have just someone that's good in the UI that doesn't really need any or a lot of programming experience, and someone that's good in the back end. This pattern doesn't work if you have full stack developers, the person that knows how to do front end, back end, and everything, because they tend to kind of blur everything together. Next pattern we're going to talk about is slightly more complicated, and that's the event-driven, commonly referred to as event sourcing or the publish subscribe model. So if we go back and look at that fictional company called Amazon.com, when you go in, place an order, there's a couple of things that happen. You have to charge the person's account, make sure that they can pay for it. You check the inventory to make sure it's there. Then you have to remove the inventory. Then you have to ship the package and update the order. Well, these things kind of sort of happen in parallel in some cases. In some cases, they're asynchronous. Fire off one, it does one thing while something else is happening. Well, this is typically done through events. So if we look back at the previous example, person clicked, I want to order something. The website or the controller in this particular case says, hey, there is an order placed. So now the application has to go and fire this order place. And it says, okay, when an order is placed, I know I need to go and do this account charge. I know I need to go to the inventory check. I need to deduct the inventory. Once all that's done, something else says, okay, this order is ready, and it fires off an event saying, hey, order is ready, come look at it. And then there's something else that says, okay, I know what to do when there's an order ready. I'm going to ship the package, and then I'm going to update the order record. So this is, if you've been in the software development field for a while, especially in the Microsoft field, this is very akin to Windows Forms development. If you've been building, the old Battleship Gray Windows Form app, you drop the button on there, you double click the button. That's an event. When someone clicks on that button, the button 1_click event, that triggers an event. Windows itself is based on events. It looks for mouse moves, it looks for clicks, it looks for double clicks, looks for key presses. It's a very common pattern, especially if your system is constantly changing and evolving. Let's say in my order place, I wanted to provide a discount for this person. Instead of updating the website, I can have something in the order place to say, hey, check this person's account to see if they've ordered $1,000 worth of products. If they did, we're going to give them 10% off. So instead of updating the website with everything, you can update the order placed handler to be able to do that. There's lots of tools and frameworks that handle this for you. One of the most common ones now is Kafka. There's Akka, AKKA. There's Azure Event Grid. There's a lot of different event publish / subscribe methods that allow you to do that. For Azure, you have Azure Messaging, Azure Service Bus, Azure Event Hubs. There's message queues, message topics. In the AWS world, there's SNS, the Simple Notification Service, Simple Queue Service, and EventBridge. This one, it's commonly used for larger systems because you kind of fire it off and you let something else handle it. By the way, if there's any questions at any point, feel free to post them in the chat. As I go between slides, I'll try to answer them. The next pattern, which is CQRS, kind of delves into that a little bit more. It is stands for Command Query Responsibility and Segregation. It's a very long name, which is why you hear it as CQRS a lot. This builds upon the event-driven So in this case, you basically have two sides. If you're looking at the graph, everything on the left side where it has command bus, command handler, the purple, blue, and event store, that's the command part. That's where the work happens. Like when you're ordering a product or shipping a product, that's handled there. The other side is the query responsibility section, and that's where, hey, I want to see my list of products. I want to see my list of orders. So in this scenario, you have something called commands. So similar to the MVC pattern, where you say, hey, this person wants to order, or this person wants to view the products. Those are considered commands. A person, or not necessarily a person, but a system will say, hey, I need to place an order. There's a command handler in there that says, oh, I know how to handle orders. Let me go and take care of that for you. And then it goes and, in the purple section, figures out domain models, goes to a repository, potentially saves off to the database, and then throws stuff in this event bus, which kind of keeps, allows for the querying to happen. So the event bus will store things like, hey, this order was there. And that allows you later on when you're going through, let's say, Amazon.com and checking on your orders to query that. It goes through a separate system that has just the data part. So you don't have to worry about mixing your business part, which is on this side, and your data part, which is on that side. Some of the advantages of this pattern is that it handles complex systems very easily because you're just putting new command handlers. Once you get the infrastructure set, you don't have to worry about it. You just add more command handlers to it, and then everything else kind of takes care of itself. It could help with performance because you're separating your queries and you're separating your queries from your real-time orders or real-time user interaction, which could help speed up databases and so on. Security could be easier also because, again, you're separating those concerns out. Some of the disadvantages is it's kind of overkill for your basic CRUD app. So if you're just building like a contact example, first name, last name, etc., might be a bit overkill for that. One of the other challenges with this one is your data can become stale at some point because there's so many steps involved. When you're putting in an order, it might not necessarily be available on the other side to query right away. Same thing with like if you're using Twitter or Facebook, when you go and like a post or heart a tweet, it doesn't update right away. You may see it on your machine in real time, but it has to go back and go over into the event bus and then back up to the query system to be able to be there. Data is also a challenge, or data synchronization between the two different quote unquote sides, but you can handle that, or there's lots of patterns to handle that. A common pattern or a common tool to help with this in the .NET world is end service. Allows you to implement this pattern. Then there's a pattern that builds upon both of these, which is called the CQRS plus event sourcing pattern. Now, if you look at this one, it's very same, with the exception of I flipped the diagram for it. Instead of everything being on the top, it's now reversed. This pattern is very similar. The only difference is the top middle, where you see an event bus and lots of command handlers. So this allows everything to come through one centralized area, and then depending on whether or not you're querying or commanding, or wanting to do extra stuff, or non-query stuff, that gets handled by this cloud thing that kind of figures out where. And then there's an event bus in the middle that kind of does all the traffic navigation between the different places to store data. This is a rather complex system, so you don't see it too often in the wild, but sometimes the event-driven and CQRS systems get combined. Next one up is the plugin model. So this you see in a lot of desktop applications. The plugin model basically allows you to build an ecosystem in your application that can inject or ingest other functionalities. So a common way to look at it is if you're using Visual Studio, everything in Visual Studio is a plugin. Visual Studio itself is just an empty shell, but then you add in ASP.NET, and that adds in certain editors and certain build tasks. If you add in products like JetBrains ReSharper, that gets added into the event. If you're using Microsoft Office or Microsoft Excel, those have plugin models to allow you to generate word art or query a database. Those are all plugins. So the plugin or microkernel allows you to do just that. If you look at the screenshot, you have your application in the middle, and I apologize for the scaling on my screen. Application and component is one word. The application in our example for Amazon has different plugin components. So it knows that there's something that handles shipping, something that handles order, something that handles inventory, and something that handles account. This is generally used for applications where you want flexibility or you don't understand the entire model or the entire user base that's going to be using the application. I've used this pattern in the past to build out things like a task scheduler saying, hey, I'm going to run a job. I'm going to build this scheduler that just looks for jobs to run. And then you can build these jobs as plugins to say, okay, at 1 o'clock, I want you to execute that. Windows Task Scheduler has something like that. Or I want to run this TPS report at 4:55 p.m. every Friday. You can have, if you have a plugin architecture, you can just add that job as an item. It's not that useful in like the scenarios where we've been thinking about the Amazon.com, but it makes sense when you're doing it for long-running jobs or something that is relatively repeatable. Workflows are a good example of this. You want to add in additional steps for a workflow or additional pieces to a workflow. Having a plugin architecture is a good way of doing that. Next one up is the buzzwords of actually before that I'll address Mahesh's comments. Joe, CQRS events, how difficult is it to implement without a cloud service like Azure? Very, very difficult. In most cases for that you need something like Azure or AWS or Google Cloud, only because they have the infrastructure in place for things like the event grid, event buses, and the ability. You don't want that, or I mean, you can, but that's a lot harder to do in your own infrastructure because of the resiliency that's needed, as well as the just the cost of having the number of services available, the uptime, the guaranteed delivery, all that stuff. It's very challenging to have on your own. Highly not recommended to do it by yourself, but use other services. Thanks for the question, Mahesh. Let's go back to the service-oriented slide. Simon, please. Thank you. Service-oriented or SOA or microservices, the bane of many architects' existence for 5 or 10 years in the early 2000s. This was everything. We have to take our monoliths and break it down into a zillion different web services, and that's what the common pattern was. That's what the common implementation was. Take a big app and break it down, but that's not really the pattern for SOA or service-oriented architecture. The idea is to get away from this one big app of owning everything. So you can think, my hand. My hand does one function, but individually there are lots of pieces. There's fingers to it. There's the palm. There's, the muscles in there. Separate all those out into their own specialties. So if we go with our Amazon.com example, you have this main page, Amazon.com. Then there is a series of services behind it. There's the account service, there's the inventory service, there's the shipping service, there's the order service. So Amazon.com doesn't have all that logic inside of that page. If you use Source on it, you're not going to see how they go and handle accounts, how they go and handle inventories, how they go and handle shipping. You might see some URLs where they go back out to the account service to say, hey, who's this person? It goes out to the inventory service to check on this product. And then behind the scenes, when you're ordering, it's going to go and do the shipping and the order. So the idea is to take your applications and start separating out your concerns. And you're not just doing it to separate it out. You're doing it for 2 reasons, or maybe 3. One is reusability. Your account service, inventory service, shipping service can be reused over in different places. Maybe you're going to white box your Amazon.com and you're going to provide the shipping service to everyone, because everyone knows Amazon's really good at shipping, or at least in the US they are. Maybe Amazon wants to make that a service so you can use Amazon shipping services as opposed to UPS or FedEx. Or you want them to be able to track your inventory. As you start breaking those things down in services, you have that flexibility. Some of the advantages, you can break down, not only you're breaking down your code, but you're breaking down your development into more, I don't say siloed, but more individual aspects. So you can have a whole team dedicated to inventory that can work with your team, with your business partners that handle the inventory. You can also work directly with your shipping services. So if you're building Amazon.com and you have to work on the shipping piece, you don't have to know the details of UPS or local carriers or Federal Express or DHL. But you can have a team that specializes in that, and they just work on that. Also allows for vendor diversity. So if we go back to that shipping service, I can add in 1 to 15 different shipping services. Let's say originally I'm only the post office, so I can write a shipping service that goes to the post office. But then I start getting big enough and I realize, well, some people want next day. So maybe I need to look at Federal Express or FedEx. So I can incorporate that into my shipping service. And the Acme widgets doesn't care. It gets a list of who the service, which places I can ship it to. And the shipping service figures out how to do that. And it works well with agile delivery practices. So you have it's a lot easier, or I would say easier, but when you're separating out the development into these different services, you can have different teams working on it or different focuses to work on them. That's why you see this one common. Next one up is the microservice pattern, which is kind of a deviation of the service-oriented pattern. And this one's a little bit hard to see, but if you look at the slides, you can go to my website and get the slides for this. See, we have a lot of different patterns here: the ambassador, anti-corruption, backend for front end, bulkhead, etc. These are all subsets. So if you take that general microservice, like the shipping service, this is how you can actually implement that or microservice, not microcenter. The ambassador pattern is used to offload common client tasks such as monitoring, logging, debugging, etc. Let's see. Oops, I went too far back. Sorry. Just trying to see if I can highlight it. That's kind of like the first block in the gateway. The anti-corruption layer is used towards the back part of it. And this makes sure that if you're doing legacy systems, like if, let's say, we had the shipping service and we had our own custom built one, but then we started integrating with the FedEx one, this makes sure that the data stays in between. The backends for front ends, or BFFs, which doesn't stand for best friend forever for those of you who were born in the 80s, like I was. This is basically a separate backend that's written just for the front end. What I mean by that is it deals with the translation between any of the services that you may be using and the website. The bulkhead pattern that handles all the interop stuff, so memory, databases, interops, networking. So that's basically if you're using something like Azure or AWS, the bulkhead pattern, they're handling all that for you. 3 different gateway pieces. Aggregation kind of takes all the request and response and eliminates the chattiness. So you get one request, you may have like 4 or 5 responses. It takes them all together and sends them back as one. The offloading kind of handles the load balancing between them. The routing handles the multiple requests. So if you say I want shipping, it knows to send it off to this one. If you want the order service, it knows to ship it off to that one. The sidecar pattern helps with or provides helper components for your container, so that it allows you to call other things that you may not be available in the main client, so to speak. And the last one, the strangler pattern. This is used, again, similar to the gateway pattern. This is used when you're in the process of migrating from, let's say, a legacy service to a new service. So if we go back to that shipping example, in the past, we're just using the U.S. Post Office for shipping. And now we started adding things like Federal Express, UPS, etc. The strangler pattern could be that in between to say, okay, for those that just use the UPS or our old legacy service, it's going to go there, while new ones are going to go to the new service. So the strangler pattern kind of handles that. This pattern also lends itself to the common pattern, the serverless pattern, or the cloud, or the, better yet, not on my PC pattern. So these are, and the reason why this is a pattern and not like software as a service, because this is a chosen way to implement things. Like I was mentioning with CQRS, you can choose to implement things yourself. You can also choose to use a third party to implement them, like Azure, AWS. Like for this example, we're using StreamYard. We're using a service to broadcast this out on all the different channels, because why bother having all that infrastructure to do it when someone else can do it? That's kind of what the serverless does. Allows you to host things like websites and notifications and databases, so you don't have to worry about all that work, and you can focus on your business model. So all these things together kind of are, ooh, that's not good. It's weird that that picture was there. Basically, what I showed you is a toolbox of different tools. You know, there's the whole, if you have a hammer, you tend to see every problem as a nail. Just because you know MVC or the CQRS pattern or the event-driven pattern doesn't mean everything should fit in that. They all have their pros and cons. Some make sense for some software development patterns, others make sense for others. So hopefully I've given you enough in this brief 40 some odd minute presentation as to which patterns to use. That being said, I'm going to open up the next 5 minutes for questions and see if anyone has any.